A basic hydraulic braking system has two main sections, the brake assemblies at the wheels, and the hydraulic system that applies them. The most widely utilized brake systems at present are, the foot-operated main brake when the vehicle is in motion, and manual-type parking brake when the vehicle is stationary. Some braking systems have all drum brakes, some have disc brakes from the front wheels and drum brakes on the rear, others have all disc brakes. A basic braking system has a brake pedal, a master cylinder to provide hydraulic pressure, brake lines and hoses to connect master cylinder to the wheel brake assemblies, and the wheel brake assemblies drum or disc that stop the wheels. The driver pushes the brake pedal, it applies force to the piston in the master cylinder, the piston applies pressure to the fluid in the cylinder, the lines transfer the pressure to the wheel cylinders, and the wheel cylinders at the wheel assemblies apply the brakes. On modern vehicles this basic system has some refinements such as a power booster. This helps the driver apply the brakes. A lever is a rigid bar pivoted around a fulcrum, used to transfer a force to a load. Levers can be used to increase force, increase travel, or change the direction of movement. There are three types or classes of levers, according to where the load and effort are located with respect to the fulcrum. The ratio of the load and effort is called mechanical advantage. Using the right kind of lever in the right way, allows a user to lift larger loads with smaller efforts. The brake pedal uses leverage to transfer the effort from the driver's foot to the master cylinder. Brake systems use hydraulic fluid in a closed system. The hydraulic brake system is governed by physical laws that makes it efficient at transmitting both motion and force. Pascal discovered the scientific laws governing the behavior of liquids under pressure. Pascal's law states that pressure applied anywhere to an enclosed body of fluid is transmitted equally to all parts of the fluid. In other words, 100 pounds per square inch, psi, generated at the master cylinder is the same at each wheel cylinder, as well as anywhere within a static system. Another important distinction to make is that liquids cannot be compressed, whereas air is compressible. Hydraulic pressure represents the force applied to the liquid. Fluid pressure is determined by dividing the input force applied to a piston by the area of the piston. The same pressure applied over different areas can produce different forces, larger and smaller. Cylinders of the same size, when the force is applied to master piston, the slave piston will move the same amount with the same force. By using cylinders of different sizes, forces can be increased or reduced. If the smaller piston is moved, the larger piston will move with more force, but it will move a shorter distance. The ratio of the area of the slave cylinder bore divided by the area of the master cylinder bore determines the hydraulic advantage. Gases are compressible. Pressure applied to air changes its volume and some pressure is lost. A hydraulic system must be free of air to operate properly. If air is in the system, the air is compressed when the brake pedal is depressed, and the brake fluid does not transmit the force to the wheel brakes. Bleeding brakes is the process of removing air bubbles from the brake system. Each caliper or wheel cylinder is provided with a bleeder screw located behind it, for bleeding brakes. When the screw is loosened, the tapered point uncovers the bleeder hole. This permits air to move up around the point, through the cross hole and out the center passageway. When the screw is tightened, the point seals the opening. The brake fluid is a special fluid with special properties. Most are a mixture of glycerin and alcohol called glycol, with additives to give it the characteristics that are needed. Brake fluid is clear or slightly amber in color. Brake fluid is specifically designed to be compatible with its environment of high heat, high pressure, and moving parts. Brake fluids are composed of three main components: solvent, lubricating, and additives. Properties of brake fluid are: correct viscosity at all temperatures, very low freezing point, very high boiling point, non-corrosive, compatible with rubber used in brake system, good lubricant, and hygroscopic, absorbs water. Standards for brake fluid have been established by the Department of Transportation, DOT, and the Society of Automotive Engineers, SAE. There are three grades of brake fluid, DOT 3, DOT 4 and DOT 5. Fluid grades are rated by the minimum boiling point for both pure fluid, dry, and water-contaminated fluid, wet. DOT 3 and DOT 4 are glycol-based, most common in use, blend with each other, and are hygroscopic, absorb water. DOT 5 is silicone-based, not compatible with glycol-based fluid, and is not hygroscopic. Most modern cars have the fluid type printed on the master cylinder filler cap. Most car manufacturers recommend changing the hydraulic brake fluid every 2 years, or 30,000 miles. Chemical energy in the battery is converted to electrical energy in the starter, which is converted to mechanical energy in the starter as it cranks the engine. Burning hydrocarbons and oxygen in the engine creates heat energy. Heat energy is converted into kinetic energy as the vehicle is put into motion. During braking, the vehicle is stopped by converting the kinetic energy of the vehicle to heat energy, which is created in the brakes by friction between moving and non-moving surface at each wheel. The converted heat is absorbed by the brake drums and rotors and dissipated to the surrounding air. Friction brake rotor set up during stress testing. Friction is a force that resists the movement of one surface over another. Friction is due to microscopic irregularities in even the smoothest of surfaces. There are two main types of friction: static friction, which is the resistance between non-moving surfaces and is present in parking brakes, and kinetic friction, which is the resistance between moving surfaces and is present in standard brakes. Friction is always measured for pairs of surfaces using what is called a coefficient of friction. A low coefficient of friction for a pair of surfaces means they can move easily over each other. Coefficient of friction varies based on composition of material and condition of the surface. For example, 100 pounds of ice pulled across a concrete floor may require 5 pounds of force to move, and 100 pounds of rubber pulled across a concrete floor may require 45 pounds of force to move. In a brake system, the coefficient of friction varies on the type of lining used, and the condition of the drum or rotor surface. Brake drums and rotors are forced to absorb a significant amount of heat during braking. Brake fade describes a condition where heat is generated at a faster rate than they are capable of dissipating heat into the surrounding air. There are primarily two types of brake fading caused by heat: mechanical fade and lining fade. Mechanical fade occurs when the brake drum overheats and expands away from the brake lining, resulting in increased brake pedal travel. Mechanical fade in drum brakes is reduced by using larger or heavier drums that absorb more heat before they expand too far. Cooling fins are also added to the drums or make them partially of aluminum to help speed heat transfer to the passing air. Mechanical fade is not a problem with disc brakes, because as a brake rotor heats up it expands toward the brake pads rather than away from them. Lining fade affects both drum and disc brakes, and occurs when the friction material overheats to the point where the coefficient of friction drops off. Some heat increases the coefficient of friction, but too much heat can cause it to drop off sharply. When the coefficient of friction drops off, friction is reduced and the brake assembly's ability to convert added heat is reduced. Track width is the measurement between the center lines of the tires when viewed from the front or rear of the vehicle. The track width is important because it determines how much weight is transferred by the mass of the car in cornering. Wheelbase is a measurement of the distance between the centers of the front and rear wheels when viewed from the side. The wheelbase is important because it determines the weight transferred by the mass of the car in acceleration and braking as well as the yaw characteristics in turning. The positions of the components in a vehicle determine how its weight is distributed while it is standing still. Every part of a vehicle has mass, and depending on where that mass is located relative to the tires, it will affect how much weight is on each tire. Static weight distribution is defined by two ratios: a ratio of the total weight on the front-rear tires, and a ratio of the total weight on the left-right tires. Balanced static weight distribution, where weight is balanced evenly between the front and rear, 50% front and 50% rear. The weight is also balanced evenly between the left and right sides, 50% left and 50% right. In reality, most vehicles never balance their static weight this well because large components and their necessary positions do not allow it. The driver's weight shifts the left-right distribution to 55% left and 45% right. The engine shifts the front-rear distribution to 60% front and 40% rear. Front-wheel drive vehicles have front-rear distribution about 80% front and 20% rear. Rear-wheel drive vehicles have front-rear distribution about 60% front and 40% rear. Weight transfer is caused by three states: acceleration, deceleration, and steering. When the car moves in one of these directions, the car's weight moves in the opposite direction and compresses the suspension in this area. During acceleration, weight shifts from the front onto the rear tires. What weight the front tires lose, the rear tires gain. The opposite of the acceleration weight transfer takes place during deceleration. During braking, the weight shifts from the rear onto the front tires. During cornering, the weight shifts from the inside tires to the outside tires. Let us imagine a car that weighs 1,500 kilograms, with a typical front-wheel drive car's weight distribution of 60% front and 40% rear. We'll assume the car's side-to-side weight distribution is equal. When standing still, the front tires have a load of 450 kilograms, and the rear tires have 300 kilograms each. The inertia of the vehicle during braking transfers force from the rear to the front effectively, decreasing the weight on the rear wheels and increasing the weight applied to the front wheels. Cars use a tandem master cylinder to provide divided or dual line braking. A divided system is safer in the event of partial failure. Fluid loss in one half of the system still leaves the other half able to halt the vehicle, although with an increase in stopping distance. Sometimes, split braking systems use two master cylinders to control each brake line. This is akin to a double safety backup. A wheel's braking ability depends on the load it's carrying during braking, so the type of vehicle is a major factor in determining how its system should be divided. Vehicle layouts can roughly be divided into three categories: front-wheel drive, rear-wheel drive, and four-wheel drive. Many different combinations of engine location and driven wheels are found in practice, and the location of each is dependent on the application for which the vehicle will be used. Because there is fundamental differences in the requirements for a rear drive brake system and a front drive brake system, different types of hydraulic system are needed. There are three types of split braking systems: vertical or front rear split system, diagonal or X split system, and L split system. Front rear split system is older dual brake systems, and is often used on rear-wheel drive and four-wheel drive vehicles. A front-engine rear-wheel drive car has around 40% of its load on its rear wheels, so its braking system can be divided in a vertical or front-rear split. This puts the front wheels in a different system from the rear wheels. If one half of the system fails the front or the back, there's still enough separate braking capability left in the other half to stop the vehicle. This doesn't work well for a front-wheel drive vehicles. A load of about 20% on the rear wheels can't provide enough braking force to stop the vehicle. Diagonal or X-split system is newer dual brake system, and is used on front-wheel drive vehicles. This system is used to ensure that the vehicle will pull up in a straight line in a brake fail situation. The left-hand front brake unit is connected to the right-hand rear unit, and the left-hand rear to the right-hand front. If one system fails, a 50% braking capability is left in the other system. Dual proportioning valves maintain optimum braking in each system. An alternative arrangement for front-engine rear-wheel drive vehicles is an L-split. The front disc brake units have 4 piston calipers. One inner and one outer piston on each front caliper connect to the right-hand rear brake unit, and the other 2 pistons of each front caliper connect to the left-hand rear brake unit. As with the diagonal split system, if there is a failure of either half of the system, it still leaves 50% of the braking capability.